Okay, I'm gonna go ahead and start with problem 15. It looks like it's gonna have 1, 2, 3, 4 parts. Okay, so the question that it's asking, a rock falls freely from rest. Okay, so here's a keyword. It's resting. So if it's resting, okay, it's resting, which means no velocity. Okay, it's not moving. Okay, so that's the first thing. And then each part of the equation represents a new scenario. Find its displacement in 3 seconds. Okay, displacement, all it means is distance. Okay, so you're going to have a rock. Okay, and let's say that this is the distance, or since it's going to go up and down, this is going to be y sub o, and we say y sub o, that means it's the initial distance. Initial distance. Okay, now if it goes up, if you were throwing it, it would be a positive, but since it's falling, it's a negative. So you should have a negative distance since it's falling. And if you throw upwards, it's positive. Okay, so now they're asking, when you throw it, or you just don't throw it, just let it fall. Okay, so the distance is right there. So it's this distance. Okay, and you can sometimes distance is referred with the letter S. Okay, so this will be 0, and they want this at 3 seconds. Okay, so now we kind of have it set it up, and here are some of the kinematics equation. Okay, and it's not really a well, you can think of it as a projectile, but we're going to use the basic equation, and we're going to use this one. Okay, and what I'm going to do is I'm going to change this. Instead of using y, I'm going to go ahead and say that it's s. I like the s. Okay, and we'll put a t because we're going to evaluate it at 3 seconds, and then we're going to say that it's s of it. I'm going to rename it I for initial, plus v sub I. This is velocity, and it's the initial velocity. Okay, times t, and then it's negative 9.8 meters per second squared. There's a constant there, half t squared. Okay, so this is the acceleration. Okay, so initial velocity, what did we say? That it's 0, so this goes to 0. And the initial distance that we're starting at, we're saying that this is at 0, and we want to know the distance, so we're going to set this to 0 too. Okay, so now the equation becomes much easier. Okay, so then it becomes 9.8 squared, and this is 9 s squared. So this cancels with that. So now we do a little bit of the use the calculator. It's negative 9.8. Okay, well, let's just, we know that it's 9.8 times 9 divided by 2, 44.1, negative 44.1 meters. Okay, so that's that. Okay, so let's do the second part. 15.b, and says find its velocity after falling 70 meters. Okay, so in 3 seconds this is negative 44.1 meters. Okay, so now they want to continue, for it to continue falling, and they want the velocity at 70 meters. Okay, you can probably use this equation. Let's see, so it says b sub y equals b sub y initial, that's what the sub O, minus gt Okay, so started with the initial velocity of 0, and this is the final velocity. Okay, so we know what this is, g, so we just need to find time. So we can use the same equation that we used before, solve for time. Or at least I think we can use. We said that it was negative 9.8 times t squared. Okay, so this traveled 70 meters. Okay, and we'll say that it's negative 70 meters. 9.8 squared t squared. So we solve for t. So basically you're going to have t centimeters divided by 4.9 meters second squared. Okay, these cancel out. So we probably gonna, since it's square root, it's gonna have an error. Well, let's see what we get. .9 raised to the 0.5, 3.7, 3.77 seconds, 7.9. Okay, so now we have the time. So now we can plug that into the velocity. This is going to be the velocity. Okay, and the velocity is, I believe, in the negative. Did they define it as a negative velocity? Yeah, they did. Because it's going in the downward. So we're going to go to this equation, and basically it's going to be 9.8 meters, and it's no 2. Okay, so it's going to be 3.779 seconds. So this second cancels that one, and you're going to have 9.8 times 3.779, or 37. 3703. Okay, and does that coincide with, I believe it does. Yep, correct. Okay, and then the time required to reach a velocity of negative 25. Okay, so that would be 15C find what time to reach velocity. Find time to reach velocity negative 25. Okay, Okay, so now what equation can we use? Okay, I believe we can use this equation. The velocity. Let's say this is going to be the final. You can see initial velocity minus gt, g, and this is 0. So we can say that this is negative 25 meters per second because it's the final velocity. So then you're going to have 9.8 meters second squared, and we're t. So basically t is going to be negative 25 meters per second divided by 9.8 meters second squared. So 25 divided by 9.8, 2.55. Yep. Okay, 15 D is the time taken to fall 300 meters. Okay. So this is a distance, so you're going to do S final equals S initial plus the initial velocity t minus 9.8 meters per t squared. Okay, so the initial velocity or distance, this is set to 0. The initial velocity was 0 because it's at rest. So then the distance is all determined by this equation. T squared. And this, the 300, is actually S final. So it's 300 meters square. So solve for t. So it'll be 300 minus negative. So we'll do that. And it'll be 300 divided by 4.9 raised to the 0.5 7.84 224. 2.4. Two, 4 seconds. Okay. And do we get the same answer? 7.82. Yeah, close enough. Alrighty.